Good morning and welcome to the live stream of the second punching shear test of a fiber reinforced slab under the scope of the FIB working group 2.4.1. We are still preparing the test. In a couple of minutes, we will start the test under the scope of this blind simulation competition. As you probably know, this is a punching shear test of a fiber reinforced slab reinforced with 60 kilos per cubic meter of steel fibers as conventional longitudinal reinforcement. On the top, you can see the zone of the slab which will be tensioned. So the hydraulic jack, it's under the slab. In this top part, you can also see a black painted zone, which indeed it's not black, it's a speckled pattern for the DIC, the digital image correlation technique. So afterwards, the deformations on that zone will be assessed, and fortunately we will try to assess in this case the crack spacing and crack width of the cracks that intersect that pattern. Okay, so we will wait a little bit more, just a couple of minutes to end the preparations of the test and check if all aspects of the test setup are good to go and the test is performed under well conditions, under good conditions. Okay, so I would ask just wait a couple more minutes and we will start the test very, very briefly. Thank you very much for following up this live stream. Good morning, welcome again. I apologize for this delay. We are right about starting in a couple of minutes, so I apologize for the delay, but there were some unexpected things to turn up here in the test. We are finalizing the verification of the instrumentation, so we have a lot of LVDT, strain gauges, just making the last minute verifications and try to guarantee that everything goes well and we have the most results as possible with good conditions. So once again, apologize again for the delay, but we will start very briefly. So probably, as you know, this is the second test. In the 15th of July already was tested the first slab under punching shear. The first slab ruptured, the rupture mode was a flexural mode, so let's see if the fibres will do their job, and once again we will have a flexural behavior or not. Okay, so we should be starting very briefly. We already have the hydraulic system working. So besides the 7 LVDTs that you see on the top of the slab for measuring deflection, we have several strain gauges to complement this the assessment of the deformation level, as well okay, so the test has started finally. Okay, 65 kilonewtons, the load at this present moment. So this is 100 kilonewtons. This initial stage is quite fast. Okay, so I already can see the first flexural cracks at 150 kilonewtons. So radial flexural cracks already, and the crack width, estimated crack width, 0.2 millimeters, 180 kilonewtons. The deflection at midpoint, no millimeters, so it's still very small. (220 kilonewtons, the load. So I will check if I can see more cracks. Four millimeters, the deflection at central point. Okay, so more flexural cracks, radial flexural cracks are appearing. Uneducated guess would be around 0.3 millimeters, the crack width, but it's, I don't know, I use glasses, so I'm not really sure. Probably a little bit more. Load? 268 kilonewtons, the load at this moment. So now we can already see several radial flexural cracks, 8 millimeters, the deflection, and 283 kilonewtons. Nine millimeters the deflection and the load 300 kilonewtons. Okay, so now the cracks, the flexural cracks are getting more visible. We are getting more cracks. In half of the slab, I can count 1, 2, 3, 4, 5, 6. In the 10 millimeters, 323 kilonewtons. Não temos régua para as... Eu tinha uma em casa para ver o tamanho das fendas. Ok. So the load, Mr. Matos, 360 kilonewtons. Não, mas era numa régua para medir as fendas, é aquela com a espessura. Okay, so I got a crack comparator. Let's see if I can give you an estimation of the crack. So I cannot get to the center point, but more near the support, the crack width is around 0.45 millimeters. And we are about 400 kilonewtons. So some of the cracks are about 0.5 millimeters. And we have some cracks that are roughly about 0.8 millimeters. So load and deflection, just 435, 18 millimeters. So the load now is increasing more slowly, and we are increasing the deformation of the slab. So the flexural cracks that were already formed are getting more visible, and we are with 444 kilonewtons and 20 millimeters of deflection. 460 kilonewtons, 21, So we are getting some cracks, about 1 millimeter crack width, some of them. For 174 kilonewtons and 25 millimeters. So now some of the crack widths are over 1.2 millimeters. Okay, so the cracks that were already formed are starting getting wider. We have some circumferential cracks in the center under the plate where we applied the load. Let's see if the fibres can bridge these circumferential cracks. 483 kilonewtons and 28 millimeters. So some of the crack widths are about 1.5 millimeters. But there are others with a smaller crack width, so varying from 0.3 to 1.5 millimeters, depending on the crack. Basilio, what was the critical deflection in the last test? Do you remember? Where the load starts decreasing? 50? No. 60? Okay. Let's see. We are about, what's the deflection, Mr. Matos? 495 kilonewtons and deflection 33. So we should be around half the test. Okay. As you know, we are carrying out this test under displacement control. So for a critical deflection of about 67 to 70 millimeters, we should be around roughly about half the time duration of the test. Okay, so here we probably you can't, but here on site we can already hear the sound of the fibers being mobilized. (500 kilonewtons, the load at this present moment, and 47 millimeters. Crack width. We have some cracks with 2 millimeters crack width, but also others with a smaller crack width. So another one here with 0.8. Obviously, at the center, they should be a little bit wider, but I cannot go there and measure them. Okay, so 507 kilonewtons and 41 millimeters, the deflection at center point. So now probably roughly at 2/3 of the test duration. Okay, so we already had the load decrease so the load is decreasing 475, and this was at the deflection 43 millimeters. So this second slab was a little bit less ductile than the first test, I think, from what I remember. Okay, so in this, it's starting at, it seems that we are having the formation of the punching shear cone. So I don't know if in this one we will have a more brittle rupture. So it seems this punching shear cone, it's getting formed. Eu acho, não sei se vai ter uma costura frágil. Okay. So the load is 378 kilonewtons. So it's decreasing. 368 kilonewtons. The load decreasing, and the deflection around 52 millimeters. Só ver o anúncio. Ah, já foi há 24 minutos. Ok. So I'm aware that get to know that Marcelo is going on holidays, so next test only for September. I hope so. So the load 350 kilonewtons. So now we are hearing that very typical noise of the fibers being pulled out. Some of them pulled out, others rupture. And deflection, 356 and 60 millimeters. Ok. Vamos fazer mais 20? Ok. So afterwards, we will try to continue the test a little bit more up to a deflection about 80 millimeters. Let's see if the slab doesn't disappoint us. No, at this present moment, the results of the IC are already not good for getting the deformation pattern. So that zone of the slab is highly cracked and deformed. Okay. The load still maintains in the same level, 360 kilonewtons. and the deflection is increasing in a constant way, 67, 68. So sim, temos de deixar. A princípio vai aguentar.
Tem controle de deslocamento,
Sim.
mesmo que haja um pulo, a carga baixa.
Okay, so the load has stabilized, so we have the reinforcement yield, and we will finish the test roughly at the same deflection of the first slabs test. So oops, and it failed. Yeah, no, the load still maintains. Yeah, a little bit decreased a little bit, but it maintains roughly at 360 kilonewtons.
É um sinal de uma laje mal calculada que dá. E quando existe tanto gás, tudo foi para o porta também.
So 340 kilonewtons, and the test should be almost finishing. We will stop the test when we have the deflection of 80 millimeters.
Aqui vocês vão apanhar o ar no fundo. Mas esse já foi.
É. Okay, so we were checking, and at this stage we already lost 5 strain gauges on the conventional reinforcement, and we will stop the test at deflection of 8 millimeters. Roughly the load was, at the end of the test, 340 kilonewtons, and I would like to thank you for following up this live stream of the second test of the third blind simulation competition, and I wish you the best of the luck for the the competitions and for the results of numerical simulations. So thank you very much. We will unload now the slab, and I wish you also a nice holidays for the ones who are going on holidays in August. Thank you very much for following me up. Goodbye.